factors of negative 55. What are you thinking of are those factors that we could think of? Negative 5 and 11. So negative 5, if I take that times 11, I get negative 55. And if I add those, negative 5 plus 11 gives me that sum of 6. Okay? So the next one we're looking at 24. Someone want to tell me their factors of 24 that sum to negative 11. Negative 8 times negative 3. Negative times negative gives us positive 24. And if I add negative 8 plus negative 3, it equals negative 11. Okay? If we're thinking of factors of negative 36, when we start thinking of those factors of negative 36, I might have negative 6. If I have negative 6, then I have to have positive 6, right? And if I have 3, I might have 3 and 12. 3 and I'm going to have negative 12, right? If I'm looking at that. And if I could have just the opposite, right? Negative 3 and positive 12. If I have 2, I'm going to have 2 and negative 18. And I could also have like 1 and negative 1, right? Or 1 and negative 36. Or just the opposite of each of them, right? Is there any way with any of those factors that I have, even if I switch the signs, that I'm going to be able to add those and get negative 12? It is impossible. So what's going to happen today, sometimes when we start our factoring, there is not going to be any way to factor that. So this one was none. Did we have another one that we could not come up with in this one? Maybe. Number 12. Because what were the two numbers when you think of that are factors? 7 and 8. And 7 times 8, if we are looking at it, if it would have said negative 56, we could have worked it, right? But in this case, none. Okay? Because they both have to be positive or they both have to be negative. All right, someone have what I should have for number 10. How about number 10, where it said factors of negative 90? Here's the deal as we start tonight's homework. You might be thinking, I don't even know. So you start with your pairs, and you might start with, okay, negative 9 times 10. And you go, nope, that's not going to work. So then you go, okay, well, if I didn't do negative 9, you can think that this is 3 times 3, right? And this is 5 times 2. So what if I go with negative 3? Negative 3 is going to have to be times how much? 30. And you probably knew that one. So that doesn't help us to get to 9, right? So now instead of 10, maybe I go with, if I look at this, it's 15, right? So if I go with negative 15, and I'm looking at then 6. Now that's the closest one, right? But that gives me, if we are looking at that one, does it give me positive 9? No, it gives me negative 9. So what do I have to do? I have to change the sign to be negative 6 and 15. So when you're doing your homework tonight and you start these factors, sometimes you're going to recognize those factors right away. Other times you won't. Sometimes people forget the 1 with a number, okay? When we look at this 80, and I'm factoring 80, did anyone have the 80 with negative 21? What'd you get? Negative 5 and negative 16. Did you get that one right away? Some people do, sometimes you don't, and especially if you have struggled with your multiplication facts ever in life, this is going to be harder for you. I'd like to say it'd be easy. If you don't have those multiplication facts down, you just struggle with coming up with factors, and it's going to take you longer. Can you use your calculator? By all means. I'm not going to restrict you. So once you think of a number like with 80 and you go, oh, I know I can go 2 and 40, and then you know I can go 5, and if you don't recognize that, you might go 10 and 8, and you can keep breaking it down, and you might want to list all those numbers as you are doing that, okay? So To rewrite it in factored form, factoring a polynomial is the opposite process of multiplying our polynomials. When we factor a polynomial, we are looking at a simpler polynomial. So if it's a trinomial, maybe a binomial or a monomial, that can be multiplied together to give us that polynomial. When we have a factored polynomial, we are usually only interested in breaking it down to polynomials that have, and here's the key thing, we want to make sure they are integer coefficients. So yesterday someone was asking me when we did that worksheet, can we have fractions or decimals? Key thing, integer coefficients. So only positive and negative integers, no fractions, decimals. So you did this problem today, like on your quiz yesterday. It said factor 2x squared plus 4x. And first thing you noticed is that they both have 2x in common. So you put 2x out in front and then you put a parenthesis. I was correcting some quizzes. There are some people that forgot to put the 2x and then they left it as x plus 2, and that would not be right. So just in case you did that. So let's take a look at this one. We're going to factor. You know how to do this. Please do this one right now. What is our greatest common factor between 2 and 8? Should be 2. Of g to the third and g to the second? G to the second. And now what we want to be thinking is, oh, I have to divide this by 2g to the second and this. That's how I got my answer down here. So when I factored that, this first one left us with just g to the first and then plus 4. Okay, you know how to do this. This one is the same as you've seen before. But this problem is a little different. So it says, what two simpler polynomials can multiply together to give this? List the pairs of factors of 20. So we start with factors of 20. We might go with what? 1 and 20? We might go with 2 and 10. We might go with 5 and 4, 4 and 5, and they have to sum to 90. This one does not work, this one does not work, this one does. It sums to 9, okay? Once we find that pair, we break down this trinomial into 2 binomials, okay? So you're going to put x plus, and does it matter if I put plus 4 and plus 5, or if someone else has their answer written this way? These are the same answer. Does that make sense? Okay? Because what's in the parenthesis, it's just putting one parenthesis first or second. Okay? So when I'm taking a look at this, how do we make sure we did it right? And some of you did this on your quiz. When you factored it, you multiplied it back out to see if it worked. If I'm multiplying x times x gives us x squared. This is going to be a plus 4x. This is going to be 5x. By adding 4x plus 5x, I get 9x. And 5 times 4 gives me 20, so it checks. So you can always multiply it back out, just like we did our multiplying, using the box, FOIL, double distributive property to check your answer. So as we look at this next one, you're asked to list the pairs that are factors of 8 and sum to -6. So the first thing you might be thinking of is factors of 8. Negative 4, -2, right? Negative times negative, that gives me positive 8, and that adds to -6. So when we write that down, -4, -2. Here's how you're always checking that middle term. You're going to multiply these two, right? That's our -4. And then the outside. So the inside and the outside, that's our -2y, that's our -4y. Okay? And then it says, if we would check it by multiplying, so if I multiply that out, this would give me what I started with. So as we are looking at that one, we already had our two middle terms. We can check by multiplying. -8y, negative times negative is positive 8. So it checks as we are looking at that question. Okay? Here's your next one. It says, list the pairs of factors of what number? Negative 36. You got to watch that sign with it. So negative 36, that sums to 9. 0. This one adds to 9. We are now going to put a plus 12, a minus 3. If I multiply the last one in each parenthesis, that gives me my negative 36. It checks. The middle, that's my 12n. That's my negative 3n. That adds to 9n. So that's how I can always kind of do that check. And this is your answer, which should be, what if in the back when you're checking your answers today, they have n minus 3 and plus 12, same answer, right? You do not have to rewrite your parentheses to match up, as long as you have the same thing in each parenthesis. All right? So this one gets a little more complicated, right? Do we have a common factor? No. So, the factor pairs have to multiply to give us negative 27 n squared. And we're just mostly going to worry about the 27 at this point, when we'll deal with the variable. You kind of see how we look at that. And it has to sum to 6. So what are you thinking right away? 27 is 3 and 9, right? And if we're going with 3 and 9, which one has to be negative to give us the sum? The 3 has to be negative. So when you look at these, knowing those multiplication factors just makes it much easier. So we're going to go with minus 3n and plus 9n. Because it was an n squared and it was an m squared at the beginning, you have to have this variable with that second number. Okay, it's not just the coefficient. And again, if I check my first one, m times m, that gives me n squared. Negative 3 times positive 9n, that gives me n squared. And to check the middle term, you're checking these two. Negative 3nm, or mn, I guess they have the m first, and positive 9mn. Okay? So as you look at those answers, and again, the order that the parentheses are in is not going to be that important as you are. So, you start with the simpler ones. The factoring is just going to get harder and harder as we do these, but they're not bad. Okay?